Hello, good afternoon. Uh, in the previous lecture, we have studied systems of irrigation. Today, I am discussing some of the what I call as topics which are very relevant to the development. The very important is water requirements, is period, duty, and now for every crop requires certain quantity of water in a certain period. Now, what is happening is that in the entire system of developing the crop, it is very much necessary to assess what is the requirement of water which is required for the good outcome of the crop from the particular type of soil and for the particular crop itself. In this regard, this discussion mainly focuses on some of the terminologies like duty, delta, and base period. Now, why it is necessary? Why the irrigation is necessary? That is the first thing. The irrigation is basically artificial supply of water that we know already we have discussed. And moreover, the India is a tropical country, and where some of the regions may not receive the sufficient water for the growth of crops. So, in that context, irrigation becomes very much necessary. And there are two things we can point out here. One is called as arid region, another is called as semi-arid region. Arid region means the area where irrigation is very much necessary for the agriculture. That means this area where the rainfall is insufficient for the growth of crop. And some of the regions, some of the areas where the area where we can grow what you call as which is we grow the crops which are not important, inferior crops, low quality crops. So such type comes under the regions or the area we call it as semi-arid regions. Now let us come to the the base period or the crop period. In the context of the what you call as calculation of the total uh, depth of water required for the entire period from the sowing to the from the harvesting, this period we usually call it as period of crop. And there are two terminologies. One is crop period and the base period. Basically, period means it is a time. It is a time from sowing. So seeds are sowing. We are sowing the seeds. From that, we are putting the water through artificial means, and after the after the harvesting, we get the crop. And the time period from sowing to the harvesting, we call it as the crop period or base period. They both are technically almost similar, but there is a slight change, we can say, in the total period. So crop period is slightly bigger than the base period. For all practical purposes, it is considered to be one and the same, whether it is crop period or base period. Okay. So therefore, as per the definition says that the time between the first watering of the crop at the time of sowing to its last watering before harvesting. So at the beginning, at first time when you put the seed to the soil, and when you put when you sow these seeds and you put the water, and that is the time starts from then and till the last harvesting, till the time of harvesting, we call it as whatever the water we are putting, that time period we call it as crop period or the base period also. And here, the literature claims that crop period is slightly bigger or more than the base period. But for all the general considerations, for calculation purposes, it is considered to be one and the same. Now coming to the meaning of delta of the crop. Delta is actually, it is the total for a fixed period and time throughout its growth of the crop. Now, it is expressed in the total depth of water, which is very much required for the development of the crop. And it is also expressed in terms of area, which is irrigated in terms of hectare meter, or we consider it as only depth of water which is required for the growth of crop. It is usually either you call it as the delta as it is referred as the total area which is irrigated in terms of hectare meter, or it is call it as only in centimeter, that is the depth of water. Both are one and the same. So as per the meaning goes like this, it is the total depth of water required by the crop to come to maturity is called as the delta. That means from the sowing to the harvesting, maturity means for the harvesting till the time of harvesting. It is this period we call it as base period or crop period, and the total depth which is necessary for the harvesting, for the growth of crop, we consider it as the delta, and this delta is expressed in terms of total depth. And please note that for the entire period, whether it is 3 months, 4 months, 5 months, whatever, the depth of water every time, let us say that it is for 6 months, it is divided into either 30 days or 20 days or whatever. Let us say that in a span of 6 months, let us say that for every one month, we consider it has 10 centimeters of depth. Then 10 into 6 months, 10 into 6, that means 60 centimeter is the total depth of which is necessary to grow crop. That means this 60 centimeter is coming up, it is considered as the delta for that particular crop. So that delta depends upon the type of soil, then the type of crop, and the nature of the soil. That is very important. How it is percolation is there. Depth of water is for every time. Generally, it is vary from crop to crop. That is very important. And each time you have to see to that, we have to consider the type of crop, type of soil, the conditions of the soil, and basically environment is very important, plays a very important role. And from season to season, during rainy season, the moisture content is very high, and in summer season it is in a reverse. So the soil is very dry in nature, complete soil is dry, and the water at that time required is very very high. But at the same time, during the particularly during rainy season, already heavy rainfall is there in particular regions, therefore the soil is already wet. So total requirement of the water for the irrigation becomes very very less or almost zero. So therefore, some of the things I want to highlight here, just here in this table, I will just show the table. Here, the average approximate values, the total depth of water required for a particular crop is mentioned in this table. Now you can go to the sugar cane. It is 120 centimeters. Rise is 120. Requires very less quantity of water. It requires very less. Means to say that this data is considered to be a very vital in assessing how much water is required for the growth of crop. And usually it varies from crop to crop, of course, from soil to soil. That's all. So therefore, on an average, whatever may be the type of soil and weather condition, sugarcane is almost 20 centimeters. Similarly, rice. These are the highest in this table, and also the fodder is 22.5. So therefore, this is the depth of water which is very much required for the growth of crop. So therefore, the term duty means the area of land, or it may be it is the depth of water. Therefore, it is said to be the delta of what you call as delta of water is very very evident for the development of the crop. Now coming to the duty means the area of land that can be irrigated with a unit volume of irrigation water. That means what is the area? What is the area which 1 cubic meter of water is going to be irrigated? That means what is the capacity? Duty means what is the capacity of 1 cubic meter of water that can irrigate. Okay, so therefore, duty refers to be area of land that can be irrigated with unit volume of irrigated water. Duty is defined as the area of land expressed in hectares can be irrigated with unit discharge. That means 1 cubic meter per second. That is a discharge of water which can irrigate for a certain area. Certain area. Let it be. It may be half a what you call as half meter square or 10 meter square or 20 meter square, whatever may be. So this is the area. What is the area which is to be irrigated? So the capacity, which is the capacity which is very much required for the growth of crop, and this capacity is referred as the duty of water. Delta means it is a depth of water, and duty means it is a capacity of a 1 cubic meter per second. That is a discharge. So one discharge, 1 unit discharge of water, how much it can irrigate the particular area. So that is referred as duty of water. Now, I can relate between two things. One is called as what you call as what is called as duty, and another is delta. Let us go to this relation, just briefly, I will highlight the important things here. Here, let it be a crop period is B, and let be 1 cubic meter of water is applied for this crop on the field for B days. B means base period. Now, the volume of water applied to this crop during B days will be volume of the water applied will be V is equal to 1 into 60 into 60 into 24. That means this much amount of volume of water is calculated for number of days. So this is for 1 day. 1 day means 24 hours. It is minutes. 60 minutes is converted. 60 minutes is converted into seconds. So 60 is minutes and seconds. So 1 is 1 day. 24 means 24 hours. So B means it is number of days. Therefore, this much amount of volume of water is applied for growth of growth of the crop. Therefore, by the definition of duty, 1 cubic meter uh, for the maturity, and it is expressed as hectares of land. And this quantity of water is expressed in terms of uh, square meter of the area. So total depth of water applied on this land is equal to volume by area, and it is equal to 86,400 B divided by 10 raised to 4 D. So 10 raised to 4 indicates it is in square meter. So 1 hectare means 10 raised to 4 meter square. So that is thing. Therefore, the entire calculation goes to be 8.64 B by D. So therefore, by the definition of total depth of water is expressed in terms of delta is equal to 8.64 B by D meters. Therefore, this is the relation between what you call as duty and delta. So delta is this, duty is this. Therefore, delta is the depth of water in expressed in terms of meters, B is in terms of number of days, and D is it is said to be hectares per cubic meter per second. So this is the entire calculations. So this is the very fundamental thing how we can express. So duty is, if you go into the depth of understanding here, duty is what is the capacity of 1 cubic meter per second, that is discharge, which can irrigate the land. It is expressed in terms of hectares per cubic meter per second, and B is base period. Okay, so an entire calculation is expressed, or entire value is expressed into meters. So this is very, very important relation. So both the things are very important for our consideration, because if you look at the table here, if you look at the table, so I think for every crop, these are the values which highlights the significance of this water requirement. Either you express the water requirement in terms of area to be irrigated, or the total quantity of water which is required in terms of depth. So both are one and the same. So therefore, I consider this as a very significant data for the growth of crops. So therefore, any agriculturist, they will consider these are the values. There are genuine values which is taken from so with the experience for so many years. These are all not the values, arbitrary values. These are all the values which is empirical values. It is from the total experience and for so many years. So therefore, the highest requirement of the what you call as the requirement of water required for the particular crop is sugarcane, and the least is fodder 22.5. So these are the things we can understand, and you what you call as cotton, a commercial crop requires hardly 50 centimeters. Okay, so like that, so it varies. Therefore, the what you call as what you call as the total depth varies with the what you call as weather conditions, or it may be the type of soil and the percolation conditions. Let us say the soil is very impervious in nature. Then, if it is impervious in nature, then what happens is the total depth of water required for the growth of crop is very less. Or otherwise, if it is pervious in nature, then the total depth of water required will be very, very high. So therefore, and also the water requirement for particular crop mainly depends upon the weather conditions also. As you know that the India is a tropical country, and mainly in particularly in summer season we are very much insufficient. We face the insufficient water for the growth of crop. So in such durations, we have to consider the irrigation as the main source for the growth of crops. In such situations, we may require, definitely we require the total depth as the highest. But it is a reverse case in the rainy season. Now let us concentrate on certain examples here. Very simple examples related to the calculations of the depth of water. We call it as duty. That is called as delta. Delta that is required. So I will just go through this first problem. Very simple problems are there. If rice requires about 10 centimeter depth of water at an average interval of about 10 days, and the crop period for rice is 120 days. Find the delta for the rice. So it's very simple calculations involved here. Now it is what you call as water is required at an interval of 10 days for 120 days. So 120 by 10 means 12. So 12 into 10. So this is the very simple calculations. This 20 every 10 days we need 10 centimeters depth of water over a period of 120 days. That means 120 divided by 12, 120 divided by 10, that means 12 number of 12 number of intervals, 12 number of intervals multiplied by the depth will be 10 centimeters. Therefore, total will be 10 into 12, so it will be 126. Therefore, the total depth of water required for the rice will be 120 centimeter. Very, very simple calculations involved here. Even you need not to be in a, not consider as a major calculation work. We'll concentrate on the second example here. If wheat requires about 7.5 centimeters of water after every 28 days. Now, the 28 days is the interval. Please note that 140 is the base period. Don't be under confusion between 28 and 140 days. It is the base period is 140 days and 28 days is the interval. So if wheat requires about 7.5 centimeters of water after every 28 days and the base period for wheat is 140 days, find out the value of the delta for the wheat. Very simple. Here also once again the same the calculation works out to be. So here the total period for the growth of crop is 140 days and at the interval of 28 days. Therefore, 140 divided by 28 happens to be 5 multiplied by 7.5. 7.5 is centimeter. This is the what you call as the depth of water for every interval. That is for every 28 days, we are putting the water to the crop for every uniform depth of 7.5 centimeters. Therefore, I consider this as a very simple calculation to understand the what is the delta for a particular crop. Therefore, I consider this as very simple calculations, and it is to understand the knowledge of the base period, what is the total depth is required. So more than the duty, it is very, very evident to understand the meaning of delta. So that is the amount of water. So duty refers to the capacity of 1 cubic meter per second. That is one discharge. And whereas delta refers to be the total depth of water which is very much necessary for the growth of crop. That is very, very important. So therefore, I consider the calculation of delta as the more important thing rather than the calculation for the duty of the particular for a particular area. Therefore, this is the I found that the relation between duty and delta. We have found what is the average values for the particular crop, and just see that the same values here mentioned as rice, what you have calculated in the uh, above example, it is rice is for 120 centimeters. So all the depth which is obtained, they are expressed in terms of centimeters. Okay. So now, of course, for every further in the future problems, we consider the relation between duty and delta as 8.64 B by D, where delta refers to be the total depth and D refers to be total depth in meters, and D stands for the depth in terms of what you call as in terms of hectares per cubic meter per second, and B stands for the base period in number of days. So this is the very important relations. Now, as I mentioned, some of the factors which is affecting the duty of water, that is very, very important to understand. The very important concept we should understand, the climatic condition and season. So therefore, the climatic conditions, see, it is for every country, there is a fixed climatic conditions. Of course, nowadays it is a lot of variations are there due to environmental problems. But overall, on an average, the climatic condition is almost similar, not much variation. And and also the seasons. So seasons, whether it is summer season, rainy season, or winter season. So these are the different seasons we experience in a entire entire calendar year. So in that we have got lot of losses of water in the form of evaporation and percolation. Let us say that uh, during the summer season, the water evaporates very quickly, very, very quickly, because you just see that the temperature in India particularly varies from 35 degrees Celsius to 45 degrees Celsius on an average from one corner to another corner of the country. So the evaporation process, it happens to be very, very fast during summer, but that is not the case in the other seasons, like it may be a rainy season or winter season. And there is another type of loss we can have, that in such situation we can what you call as during when there is a loss of water due to evaporation, then we require higher depth of water for the development of crop. That is one thing. And another thing is that another important thing, that the type of soil, what type of soil it is. So if the soil is permeable, then it is very, very difficult to hold the water for a particular season, particular duration. Therefore, the duration happens to be very less, as I mentioned in the problem. Some of the durations may be 10 days, the interval may be 10 days or 28 days. Now, if it is a uh, permeable type of soil, then the percolation happens very fast. In such situation, the interval becomes very less. So therefore, number of intervals becomes more. When the interval period is less, then number of intervals becomes more for the entire base period. So if it is base period is fixed, it may be 4 months or 6 months. For particular crop, the base period is fixed. But if you reduce the interval from it may be 30 days to 10 days or 30 days to 20 days, then naturally the depth of water required for the entire base period becomes more. Highest happens uh, the rice or it may be sugarcane or whatever. So therefore, you can say that this is the type of the problem we all the agriculturists are facing. So therefore, that is one thing. The type of soil, and another is season. So these are the two factors we consider as the factors affecting that uh, duty. Okay. So therefore, that is the one thing. Okay. So that is a very, very important consideration. Now, rainfall intensity is another factors we have to be considered. So therefore, the rainfall intensity is another problem in particular in India nowadays because of the uh, climatic changes. Weathering the climatic changes mainly depends upon the ongoing environmental issues, and because of that, lot of changes are there. So therefore, that is also affecting the what you call as uh, affecting the duty of the particular year for the particular crop development. So therefore, the rainfall intensity is also very, very plays an and soil, the type of soil is also that, as I mentioned in the earlier discussion, the type of soil is a very, 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 very important considerations. So the type of soil is if the permeability of the soil, permeability means a material which allows to flow through. The material which allows to flow through, we call it as permeable. So such type of material, we call it as permeable type of material. So if the soil becomes, if it is permeable in nature, then irrigation is very much evident, and it becomes at the highest of order. Therefore, in such situation, the losses due to the percolation becomes the highest. Therefore, it is you need it is irrigation is only the alternative for this. Therefore, uh, if it is rainy season is not sufficient, you have to fed the water from the different sources through irrigation methodologies. So therefore, it depends upon the type of region and the type of soil and the type of system what you are irrigating. Therefore, all this the duty mainly depends upon the soil conditions. And another thing is that the efficiency of the methodology you are adopting for the cultivation of the crop. So, whatever the cultivation is there, whatever methodology you are adopting, whatever may be the methodology of cultivation, this mainly the efficiency of this methodology mainly depends upon the what you call as the technology we have got for the growth of crop. And if the efficiency becomes very important to understand the what you call as duty of the particular for area to be irrigated. Therefore, the what you call as is and faulty and less efficient. If it is faulty and less efficient, then resulting in the wastage of water. So that is very, very important. Some of the cultivation methods which happens to be there are a lot of wastages. In such situations, the efficiency becomes very less. So therefore, efficiency means we have to have a lesser input and higher output. Okay, so that is the expected efficiency for every methodology of cultivation. Now, coming to the last discussion about what you call as the importance of the duty. So, why it is necessary? Why the duty is necessary for a particular uh, growth of crop. It helps in the designing efficient canal system. So therefore, all the irrigation methodology mainly depends upon the what you call as mainly depends upon the what you call as the particular area and the type of irrigation what you are adopting. And the irrigation is mainly is the factors which are affecting here are some of the irrigation structures. Either it may be a dam or it may be a canal or it may be aqueduct, weirs, barrages or weirs, all sorts of irrigation structures. Now, what are the types of irrigation tools we are making use for the growth of the crop? And the importance of duty becomes very important because of the we have to design an efficient canal. That means efficient means once again coming to the same point, that is what you call as without wastage and lesser input and higher output. That is the main goal of this entire the system design for the supply of water. Knowing the total available water at the main canal, we have to uh, find the duty for all crops required to be irrigated in the different seasons. So therefore, with this entire discussion, we can conclude this lecture with some of the important ideas, like what you start with the what you call as starting with the what you call as the meaning of base period. Base period is the period from the starting of the sowing to the end of the crop, that is harvesting. So we call it as the base period. And the crop development happens in a certain period, varies from what you call as 3 months to 6 months. And this period we call as either it is a base period or crop period. In technically, both is considered to be same. Delta is the total depth of water required for the growth of crop, and duty is the what you call as the efficiency of 1 cubic meter per second, that is discharge, that can irrigate a particular area of land. And we found that some relations here, very simple relations between uh, delta and duty. So delta is equal to 8.64 b by d, where d is the depth in what you call as depth, or we can express in terms of hectares per cubic meter per second. And b is the base period in days, and delta is referred as in the total in meters. And also we have highlighted some of the depth of water required in terms of centimeters for the growth of crop. And also we have gone through certain examples here, very simple examples we considered here. So these are the two examples where we have found the delta for a particular type of crop, either it is a rice or and rice or it is a wheat. And also we have highlighted the crops which are having the highest in depth of water like sugarcane or rice, and the lowest as fodder. And some of the factors affecting the duty of the duty of water, like climatic change, climatic and seasons, and also the rainfall intensity, the type of soil, and also of cultivation. So with this, I conclude this lecture, and next class we'll study the design of canals. Thank you. Thank you very much.